In this lecture, I'm going to talk about the first strategy for loading related objects, lazy loading. So I've got this piece of code here. First, we select a course with ID 2 from the database. Then we iterate over its tags and display them on the console. Now in terms of query execution, when this line is executed, Entity Framework is going to send a query to the database to select a course with ID 2. And the reason for that is because we're using the single method here. So any of these singleton methods, like single or default, first or default, count, max, average, methods like that cause an immediate query execution. But this course object here does not have its tags initialized. Later, when we get to the for each block and we access course.tags, Entity Framework is going to send another query to the database to get the tags for this course. And this is what we call lazy loading. So related objects, like in this case tags, are not loaded immediately. They're loaded on demand when we access them. Now let me show you how lazy loading is implemented. So we go to the course class. Look at this tags property. This property is declared as virtual. And this is the key to enable lazy loading on this property. So basically, at runtime, Entity Framework creates a new class that derives from our course class, and we call this course proxy. The reason we call this proxy is because this class looks exactly like our course class, but it has some additional behavior. In this case, it's going to override the tags property with some piece of code like this. So in the getter, first it checks if the tags field is null. If it is null, it's going to use context to load the tags for this course. Now the actual implementation of this is a bit more complex than these two lines here, but this is just to give you an idea. And finally, we return the tags field. So the first time we access the tags property, because the tags field is null, it's going to be initialized and returned. And anytime after that, when we access the tags property, we're going to get this tags object into memory. Now let me show you this proxy class and runtime. So back in Visual Studio, I'm going to put a breakpoint on this line with F9 and run the application in debug mode with F5. Okay, now I open up the watch window and put the course variable here. Next, I step over this line with F10. Okay, Entity Framework executed a query. Now look at the course object here. Look at its type. It's of type system.data.entity, the dynamic proxies, .course underline, and a sequence number here. So this class you see here, course underline, whatever, is the dynamic proxy that is created at runtime. Now one tricky thing with lazy loading is, if I expand this variable here and look at the tags property, it gives me the illusion that the tags are loaded immediately ahead of time, not inside the for each block, because currently we are not inside the for each block yet. So the watch window in the debugger can be misleading. The reality is, as I expanded the course object here, Entity Framework ran another query to get the tags for this course. Let me prove that to you. So I'm going to go to SQL Profiler. Okay, take a look here. I've highlighted this item here, and this is the actual query that was first sent to the database to get a course with ID 2. Note that here we're only selecting the simple properties of the course class, like ID, name, description, and so on. We're not selecting any navigation properties. So we are not selecting author or tags. We're only selecting author ID, which is the foreign key property. Now here we have another query. Look, here we're selecting the ID and name from the authors table where ID is set to this parameter, which is 1, which is actually the author ID for that course. So Entity Framework sent a separate query to get the author for this course. And look, here's another query to get the tags for this course. So here we're selecting from course tags, doing a join with tags, and in the filter, we get the tags for the course with ID too. So in fact, as you see here, we have 3 queries, one for the course object, one for the author, and one for the tags. So remember, when you inspect your objects in the debug mode, Entity Framework is going to load related objects using lazy loading, and this is not immediately visible, unless you look at SQL Profiler. Now, in terms of best practices, lazy loading can be useful in situations where loading a graph of related objects is going to be costly. For example, imagine at your application startup, you want to load a bunch of related objects, and this is going to be costly, so it can cause a delay in your application startup. In that case, you can use lazy loading to load only the main objects and load the related objects on demand. So as the user navigates in your application, clicks on different buttons, opens up different pages, then you can load the related objects. And this scenario makes sense in the context of desktop applications. So it's better to avoid lazy loading in web applications. Because in web applications, we get a request, and in order for us to create a response, we need to know ahead of time what data exactly we're going to return to the client. As the user navigates in the application, we're going to get a brand new request, so we're not going to have a context object or a course object hanging in the memory so we can access its tags or author property. So lazy loading in web applications can cause unnecessary round trips to the database, and this will have an adverse impact on the performance of your application. So with web applications, you can disable lazy loading by not declaring your properties as virtual. But this means you need to make sure to follow this rule for every navigation property. There is a better and safer way to guarantee that lazy loading is disabled in the entire context, and that is using a configuration. So we go to Pluto context. In the constructor, I'm going to use this dot configuration dot lazy loading enabled set to false. This will guarantee that lazy loading is not going to be used in this context, and whether I use virtual or not is not going to make any difference. My personal recommendation is to avoid using the virtual because it's just adding an extra noise in your code without giving you any values. In the next lecture, we're going to take a look at N+1 issue, which sometimes comes in technical interviews. I hope you enjoyed this lecture and thank you for watching.